Okay, 4.8 number 1 says the sum of a number, let's call the number x, and it's square. So then if you square it, that would be the square of the number. It's square. So if it says the sum of the number and it's square, we're going to take those two things and we're going to add them. So we have x plus x squared. The sum of a number and its square means equal as we kind of interpret the sentence. What is it? It is 72. So find the number. Well, how do we solve this? Well, you see a square in it. So you know that your options are factoring, quadratic formula. There's a few other ones, but those are the two main ones. But in either one of those cases, you have to get all the terms on one side and 0 on the other. So let's do that. Let's move 72 over here. And when I rewrite all these, let me write them in order of the biggest exponent down to the smallest exponent. That means I'll put the x squared term first, and then I'll put the x, and then I'll put the minus 72, and it's equal to 0. Now, if you think about it, what do you multiply to get negative 72, and it adds to give you 1, because there's an invisible 1 in the middle there, in there. Well, we know that 9 and 8 are 72, and they're 1 unit apart, so that's probably how we're going to need to do this. If we want a positive one, we could say, well, 9 minus 8 is positive 1, and then if you check it, yes, 9 times negative 8 is negative 72. So we could factor this as x plus 9, and x minus 8 is equal to 0. And then to solve it, we just take each one of these and we set them equal to 0. Okay. So if we solve the first one, you subtract 9 from both sides, we get, well, the number could be negative 9. But there's also, we could get another answer. We could get x equal 8. Now let's check it out. Is negative 9, let's check the answers. Negative 9 plus, what's negative 9 squared? 81, is that equal to 72? Yes, that would work. But what if it were the other number? What if it were 8? 8 plus, what's 8 squared? 64, is that 72? Yes, so there's two possibilities. X is negative 9 or x equal 8. If they had said something like a positive number, we would have just picked 8. But since they didn't say anything like that, we're just going to say there's two possibilities, negative 9 and 8. Okay, so for number 3, which is the next one assigned, it says find two consecutive odd integers whose product is 143. So let's call the first odd integer x. And to get to the next odd integer, we'd have to add 2 to get to it. So that'd be the second consecutive odd integer. And it says the product, so that means take these two things, the x and the x plus 2, and multiply them, because that's what product means. And what is the product? It is, so we write down equal, it's 143. Okay. Now to solve this, we will have to get all the terms on one side and then try to factor it, okay? So let's see, I got to simplify the left side first. X times x is x squared, and x times 2 is 2x. And then I'm going to subtract 143 from both sides. So I'll just do all that really quickly here. So it's x squared plus 2x minus 143 equals 0. Now, I don't know about you, but 143 is not a very familiar number for me. So if I got to factor it, I think, okay, maybe 3 goes into it. Let's see. 3 goes into 14 4 times. That would be 12, be 23. Nope, doesn't work, does it? Let's try. 7 doesn't go into it. Let's try 11. Let's see. 143 divided by 11. It goes in there 13 times. So it's 11 times 13. So if you look at that, that's the only way you could factor 143. So what multiplies to give me negative 143 and adds to give me that positive 2? Well, let's try that 11 and this 13 that we found over here. If I want it to be a positive 2, it would need to be a negative 11 and a positive 13, and that works. So this factors into x minus 11, x plus 13 equals 0. So if I go to solve, we take each factor and we set it equal to 0. Okay, so let's add 11 to both sides here. We get one answer is x is 11. And over here, if we subtract 13 from both sides, we get x equal negative 13. So now there's two answers. If the first number is 11, the next odd would be 11 plus 2 would be 13, okay? So that's one set of answers. Or what if the first number were this negative 13? If you add 2 to it, you'd get negative 11. And that would also work. So there's two sets of answers here that you could get. Okay? All right, let's look at number 5. 5 says a rectangle is 4 centimeters longer than it is wide. So if I call this W, how long is it? It is W plus 4. It's 4 more long than it is wide. So the length is W plus 4. And it tells us the area is 117 centimeters squared. Now when I see they're giving me the area, I need to think, ooh, I know the area for a rectangle. Area is length times width, right? Well, they want to know what the dimensions are. I know what the area is. It's 117, so let's plug it into the area formula. Now, length times width. I know that width, I called it W up here, just because when I was reading the problem, that just seemed to be a normal thing to do. And its length is W plus 4. So instead of putting length times width, I could just say W for the width, and for the length, let me put in W plus 4, because that's only one variable, because the length is 4 more than the width, so we could just express it that way. So I need to simplify I need to simplify both sides, move all the terms to one side. So let me see. If you don't like looking at this right-hand side the way it is, multiplication says the commutative property of multiplication says we can switch them like that. And maybe that'd be easier for your brain to kind of wrap itself around. W times W is W squared. W times 4 is 4W. So let's get all the terms on one side. Let me subtract the 117 from both sides. And I get 0 is W squared plus 4W minus 117. Now, I've got to figure out how do you get 117. I'm going to see, let's see, we're trying to see what multiplies to give us negative 117 and adds to give us 4. Let me think. Let's try to see if 3 goes in there. 3 goes into 11 3 times. Yeah, it does. 3 times 39 is 117. And then this factors into 13 times 3. So let's see. How could we get a difference of 4? Oh, I see it. Okay. 3 times 3 is 9, isn't it? And then you got a 13. 13 times 9 would be 117. I need to get a 4 out of it. So I need to have 13 minus 9 is 4. Now, negative 9 times positive 13 would give me this negative 117 that I need. So my missing numbers were negative 9 and 13. So this factors into W minus 9 times W plus 13 is equal to 0. Okay, so let me go to another page. 9 times W plus 13 equals 0. Okay, we know that length is W plus 4. Okay. So now, let's solve this. If I have two things that multiply to give me 0, I set each factor equal to 0 because either one could be 0. And we solve. We add 9 to both sides on the left one. I get W is 9. So if my width is 9, then my length would be 9 plus 4, which would be 13. I could have just plugged it in up here, right? 9 plus 4 is 13. Now, what about this other one? Let me subtract 13 from both sides. I get W is negative 13. Hey, is it possible to have a width of negative 13? Can you have a negative width? No. In this problem, this answer does not make sense, so we just throw it out and we say, well, there's only one answer here, and it's the width is 9 and the length is 13. In number 7, we see the area of a right triangle. So let's draw one. Here it is. Okay? They tell us the area is 44 meters squared. Now I know that the area of a triangle is 1/2 the base times the height. It says find the length of its legs. Well, I could call this leg the base and this length the height, right? So, I mean, it's still working with my formula. Find the length of the legs if one of the legs is 3 meters longer than the other one. Okay, I tell you what. It doesn't matter which one I choose. Let's say I'll put the height and I'll put the base, okay? Let's call the height x, and let's call the base x plus 3 because it said one leg is 3 meters longer than the other. So if I call one leg x, the other one is x plus 3. So I could put all this stuff in this formula up here. When I saw that they said the area of a triangle, I knew I needed to write that formula down because if I don't have anywhere to start, right? So here's what I do. I say, okay, well, what is the area? Well, they told me it was 44. We can plug that in. Now, we called base and height x and x plus 3. So let me just put x times x plus 3. Base was really x plus 3 and the height was x, but because it's multiplication, I can switch the order. So I have 44 is a half times, let's see, a half x times x would be a half x squared, and a half x times 3 would be 3 halves x. Now, I don't want to work with fractions. I just don't like them. So I'm going to multiply everything in this whole equation by 2, and I'm going to clear out the fractions that way. Remember that we can do that to get rid of fractions. 2 times 44 is 88. 2 times a half is 1x squared, and 2 times 3 halves, the 2's would cancel out, and you'd have plus 3x. Now, if I want to get all the terms on one side so I can factor it, let's just subtract this 88 from both sides. I'd get 0 is x squared plus 3x minus 88. Now, if you think about it, how do you multiply to get 88 and at the same time have, or negative 88, and have something add up to be 3 at the same time? Because remember, we're multiplying to get the number on the end, adding to get the number in the middle. Well, 11 times 8 is 88. And if you were to subtract, if you say 11 minus 8, that'd give you this 3 down here, and 11 times negative 8 would give you this minus 88 up here at the top. So my numbers are, if I factor, it's x plus 11 and x minus 8. Let me go to a new, x plus 11 and x minus 8 equals 0. And I know that my sides are x, and then I have to add 3 to get to the other side. All right, so let's solve. We could take each factor and set it equal to 0 to solve. So we take each one of those parentheses, and what's inside, we set it equal to 0. All right. For this first one, I'm getting x is negative 11. Can I have a side of a triangle be negative 11? No, there's no such thing as a negative side length, so we're not going to use that one. We're going to say that doesn't work in this problem. But what about this other one? Well, let's solve the second one. We could add 8 to both sides, and we get x equal 8. Hey, that works. All right, so if one of my legs is 8, the other one is 8 plus 3 is 11. All right, let's think about that. The area was 44, right? Well, what's a half of 8 times 11? A half of 88 would be 44. Hey, that works, doesn't it? So if I check my work, I can actually see that these are my legs. The legs are 8 and 11, and whatever the units were there, they were probably meters. So 8 meters and 11 meters.